So hello, today in this video we're going to look at an introduction to vectors. So let's have a look at what we're given today. Okay, so let's read what's going on here. So let's consider the example of velocity. So the velocity of a car is 60 kilometers per hour traveling southeast. Our car's velocity has a magnitude of 60 kilometers per hour and a direction of southeast. This means that velocity is an example of a vector. Yes. So a vector is a quantity that has both magnitude and direction. So in this case, let's use another color. Our velocity has a magnitude, 60 kilometers per hour, and it has a direction, southeast. So velocity is an example of a vector. Acceleration is another example of a vector. For example, the acceleration of a plane is 300 kilometers per hour squared northwest. So again, let's use a different color. Our acceleration, it has a magnitude and a direction. Again, we have a magnitude of 300 kilometers per hour squared and a direction of northwest. Visually, how a vector is represented. So vectors are represented by an arrow. So the length of the arrow represents the magnitude of that vector, and the position of where the arrowhead is in direction represents the direction. So let's try and represent our velocity and our acceleration as a vector visually as some kind of arrow. Okay, so let's first put our little north, south, east, and west. Whoops, I got east and west wrong. Well, that's not good. No, I got them right. Oh, geez. Okay, let's turn my phone off. Making a lot of noise here. Okay, so we have our directions, north, south, east, and west. And we're going to draw our velocity. So let's look at our velocity. Our velocity is 60 kilometers per hour. And it's traveling southeast. So which direction is southeast? This is south, this is east, southeast is in the middle. It's like 45 degrees down from the horizontal. Okay, so let's say about there. Okay. And I can't quite measure it, but let's say this is our velocity. Let's call it V. And it represents this 60 kilometers per hour southeast. So this length, this magnitude represents 60 kilometers, represents a magnitude of 60 kilometers per hour. And the direction, why don't we put some reference here? The angle, a 45-degree angle from the horizontal represents the fact that it's southeast. Okay, that's our velocity. Now let's pick blue for our acceleration, a bit smaller. So our acceleration in this example is the plane's accelerating at 300 kilometers per hour squared northwest. So again, north. Where's our north? Our north and our west. So northwest is going to be going in that direction. So 45 degrees above the horizontal. And it's 300 kilometers per hour. Okay, so if we're going to do this to scale, and if this yellow length is 60, well, our 300 is going to be very large. So why don't we just pick another scale? And we're going to say that this blue arrow here, which is kind of parallel to the yellow one, and our arrowhead's going to point in that direction because we're going northwest. And let's put in the horizontal. Okay. This represents, and this angle here is 45 degrees. So this arrow, we're going to call it A, represents our 300 kilometers per hour squared northwest. Good. So that's our acceleration, our velocity, and we've represented them as vectors, so little arrows of a given length to represent the magnitude, and pointing in a certain direction to represent the direction. Okay. That's a little introduction to vectors. That brings us to the end of our session. If you have any questions, send us a note at info@raisedbymarks.com or give us a call, day or evening, and we'll be happy to answer your questions. Thank you for watching.